Okay. Можно читать, да? So I'm going to talk about the asymptotic behavior of the colored Jones polynomials, and actually today I will consider mostly the case of the eight-figure knot. So first I think...
Sorry, but I can't see anything.
Что?
Я ничего не вижу, честно говоря.
Ой.
Зато мы слышим.
Да. О. Теперь вижу. Саша, а нужно включить запись или все нормально?
Я проверю.
Ага.
Все, можно дальше? Да, Саша? Okay, so I don't want to give the full definition of Colour-Jones polynomials, but I'm going to say that Jones polynomials is a family of polynomials that depends on some parameter n, which corresponds to the n-dimensional irreducible representation of SL2. It depends also on some knot. It also can be defined for different links, but today we will work only with knots. So I'm going to write, so K is a knot. And also it depends on some parameter Q. Yes, as I said, it corresponds to some n-dimensional representation, irreducible representation of SL2. Also, we normalize it. First of all, it's polynomial of Q and Q minus to the power of -1, and we normalize it in such a way that this polynomial for the unknot is equal to 1. And also we...
This is for each n, yeah?
Yes. And also for n equals 2, the Jones polynomial, the Colour-Jones polynomial is just the ordinary Jones polynomial, which can be defined through the skein relation. I know, maybe уже можно не повторять, да? Okay. So the thing is to study its asymptotic behavior as n goes to infinity. And
just write down that this is the ordinary Jones polynomial.
Okay, so first I would say that the motivation to study the asymptotic behavior of this polynomial as n goes to infinity, and Q will also be some function of n. Actually, usually it will be something like exponent of some xi divided by n. So, so we're going to study somewhat of the form of this form for different xi. And one of the possible motivation for this is that the conjectures are that the constant that will appear in the asymptotic formulas correspond actually to some topological constants of our invariants of our nodes. So now I'm going to write some conjectures about the behavior of such things. And they are not proven, but they can be checked for some simple nodes. And today I'm going to speak something about, to tell something about the 8-figure node.
Will you please indicate the authors of the paper you are talking, you're mainly based on?
Yes, it's... the general statements are conjectures, but there are only some checks for like torus nodes or Whitehead nodes or nodes with small intersection numbers. So no general statements are proven in like. Okay, so да, авторов. Сейчас я чтобы не ошибиться. Okay, so где можно наверху, да, это лучше название написать. Сейчас. Секундочку. By the work of Hitoshi Murakami and okay. Okay, so so the first conjecture was proposed by Kashaev when he studied the not invariant, which I don't know if it has some name or not. It appeared from some quantum D logarithm and some R matrix representations of a knot, but later it turned out that it just equals to the Color-Jones polynomial evaluated at the point Q equals to PE divided by N. So Kashaev studied this kind of invariant, and his conjecture was that for a hyperbolic node, we have the following asymptotics at the logarithm divided by n equals just the hyperbolic volume of the complement of a node in the sphere divided by 2p. So the next yes, it's like Kashaev conjecture. The next conjecture that was proposed is the generalization of this one to the case when a node is not a hyperbolic node. So for any node A, we can in the sphere we can consider this the same thing. And the conjecture is that this asymptotics is just the volume where here I mean the simplicial volume or the Gromov norm of this manifold. Yes, and also it is chosen in such, it's proportional to this one for a hyperbolic knot, so we choose it in such a way that for hyperbolic knots the Gromov norm is just the hyperbolic volume.
What is the difference between these two conjectures?
This conjecture follows from this one, but here we consider not only hyperbolic knots but also any.
Yeah, but for hyperbolic knots,
It's just the same, yes.
just this, sorry, logarithms of what?
This is the Jones polynomial evaluated at the point to the power of 2pe divided by n.
Yeah, but this is exactly the same as this.
Yes. I'm just historical. So the next conjecture was complexification of Kashaev conjecture, where we study not only the asymptotics of the module of the logarithm, but also of the whole logarithm. So here, some complexification of.
So let me ask Maxim Eduardovich. Maxim, whether what we know that the weight system associated to the Collard-Jones polynomial is the GLN weight system. Nope. It is nope. It is SL2 in an appropriate representation, in representation number n. Does it make any sense to consider similar asymptotics for the values of this weight system?
I will give a very sophisticated answer. Yes.
Okay, we never considered these asymptotics, but probably it makes sense.
Okay, so the next is a complexification of conjecture 1, where we study the asymptotics of logarithm, not only its model. And here the conjecture is that it equals to this one, where CS is the Chern-Simons invariant, which yes, it's in this conjecture it's the Chern-Simons invariant associated with the Vich-Witte connection. So here we can see the more interesting invariant than just the hyperbolic volume in the asymptotic formulas. And the last one conjecture.
Sorry. Once again, what is the difference? We include not only the real part of the logarithm, but also the argument.
Yes.
Yeah, I see. Also the argument, and it happens that
it's conjectured, yes, that it equals to.
That the imaginary part of the argument defined by the argument is the Chern-Simons invariant. By the way, I do not remember what is the Chern-Simons invariant. Probably you can. It's some. You have a hyperbolic manifold, a complete hyperbolic manifold, three-dimensional manifold, and you have the tangent bundle and the Levi-Civita connection associated to this metric. What characteristic class is called Chern-Simons? You don't know.
If I'm not mistaken, it's yes, yeah. Oh gosh, but ну там, ладно, сегодня у нас другой будет класс. Okay, so the last conjecture is the generalized volume conjecture for Xi not equal to PE, but Xi is close to PE. Then we have this conjecture that refines also the volume conjecture that we have some constants. Yes, so here d is just some constant, and these two functions, t of xi, tau of xi and s of xi, actually are connected with some Chern-Simons invariants and some joint Reidemeister torsion, which also associated with some representation, but I think I will try to illustrate it for the A figure node. So these are the general conjectures, and as I said, they're not proven, but they can be checked for some more simple cases. So today, могу на это доски писать, да? So today I'm going to consider the 8-figure node. Maybe it's better to draw it. So it's something like so this thing it's a unique node with an intersection number 4, and there are some known results for the asymptotics of this thing for different Xi, which I'm going to state, and today we will consider the case when Xi is real in more than some number. Okay, so to formulate some results, I will need to define some functions. So we will need this. I don't know, maybe it's better not to write it precisely, but I just say that what conjectures from this list are proven. So the volume conjecture is proven, and also the generalization. Yes, and also the conjecture 4 also proven. So conjectures 1 and 4 are proven for this node, and also it was considered to take different Xi, and the asymptotic behavior is calculated for some other than general conjectures choice of Xi, but I think I'm not going to state all the results because we have a lack of time. So I think to say what is K here, I need to define some functions. Maybe here I will just write them. So I will need to state the result. I think, yes, what I need. Yes, I need. Yes, I need this function. Where we choose the branch of our costs in like some certain way. Let's say like this. Okay, so also I need this function. Here I use the notion of de-logarithm function. Let us write it here in the following way. So I need another function like this. Okay, so now we defined some functions and we can state the result. The theorem is that when Xi is real and model Xi is more than K, K is just, I'm not mistaken, K equals logarithm of, it's a fixed number, and it's chosen in such a way that phi of K equals 0. So for this choice of Xi, we have the following asymptotic formula. So this is the main result, and this sign means that this one is this one multiplied by 1 plus by the thing. And another interesting for us observation that I'm going to say like in the end is that these functions that appear here, they are Xi and S of Xi, they are related to some invariance to some topological invariance of our node, namely like the Chern-Simons and the joint Reidemeister torsion associated with some representation. Okay, so
sorry, these are very nice formulas. We have to look at them more attentively. So we have some boundary K, yeah, of rather strange form, which is logarithm.
It's chosen in such a way that this function that appears everywhere is 0 at this point.
This is
the
0 of some function phi, which comes from where? Phi of Xi is arc
cosinus of cosinus Xi minus 1/2. It's from from a complex plane with some cut, I suppose. And we choose a cut from minus infinity to 0.
A cut from minus infinity to 0.
For the logarithm, yes.
And
So
this is the same as the logarithm.
I think I can draw the graphics of its real and imaginary part.
But it's also important how it looks like on the complex part. Probably pure real. What it is on the real line, it's not that interesting, we can imagine. Okay, so there is some function which arises in all formulas of this type, yeah?
Yes, I suppose. And also we use always the logarithm function.
And d logarithm, how d logarithm comes into picture. S of xi is the d logarithm of e to the power
Of minus xi minus 5 xi.
minus xi minus 5 xi. In fact, we are interested not in the function phi, but in the function xi plus phi of xi, yeah?
Yes, but also we have here its multiplication, I suppose. Yes.
And then we have something similar looking like t of xi, yeah?
Yes.
And t is more or less this tau, yeah? Which appears. Is it true that this t of xi plays the role of tau of xi?
No, I think it's different. Maybe no one. Oh yes, actually there is. Yes, it's the same. It's the same in the different formulas.
Yep.
Yes.
Can we replace the letter t capital by tau?
Yes, but in this case, t is just defined here. Ну, типа, чтобы одинаково просто выглядел. Ну, давайте.
Чтобы не было, вот, да, чтобы не было вопроса о том.
Ну, вообще, можно, да, по-русски скажу, но вообще это немножко про разное, потому что там асимптотику вообще в другой точке рассматриваем. Но они совпадают.
Это
вот,
асимптотика в другой?
Ну, типа, да, потому что...
Почему?
Потому что общие все предположения, они про кси рядом с точкой 2π, типа. Вот. А это для действительного кси.
Это для действительного
Вот,
кси.
поэтому это вообще-то,
Сейчас, но...
это некоторое утверждение, что вот в той формуле то, что там, это совпало с тем, то, что здесь, поэтому...
Близко к 2π, а здесь кси
Да.
вещественная, но функция играет ту же самую роль.
Ну да.
Так. Максим. Ну, я просто к тому, что функции такого вида у нас возникали functions of this type arise rather frequently in enumerating maps, graphs on surfaces of different types. Синус гиперболический в знаменателе. Enumeration of rational. Окей. А показатель степени там тау кси в степени 1/2. Почему это так интересно? Почему? Что нам мешает считать тау от кси в степени 1/2 просто какой-то другой функцией тау1 от кси? Почему 1/2 здесь существенно?
Ну, я бы ответил так, что потому что вот в таком виде тау от кси, оно там какому-то топологическому инварианту соответствует.
То есть это уже какая-то tau of xi is a neon function.
Yes,
And
yes.
which behaves nicely and it corresponds to some topological invariant, like Rademaster torsion or Chern-Simons invariant.
Yes.
And that's why we use this
Yes.
form of this.
That's tau is exactly the Rademacher torsion. Ну вот эта теорема.
Yeah, and this D is also 1/2. Yeah, in this asymptotics.
Yes.
N over xi to the power 1, n over xi to the power 1/2. Is it true that it is always rational?
I don't know.
You don't know. Okay, let's continue.
Что еще раз? Трилистник?
Трилистник. С трилистником the trefoil is not hyperbolic, unfortunately. All torus knots are not hyperbolic. Almost all the other knots are hyperbolic, including the figure 8 knot, but torus knots are not hyperbolic.
Ну, да, вторая, да, она для вот тороидальных, по-моему, узлов, она ее проверили. Сейчас не для тороидальных, как сказать, короче говоря, как называются узлы, которые сами как бы из тора состоят только? У которых граница тора? Это симплициальный объем.
Это
типа норма
это
Грома.
полное гиперболическое многообразие постоянной кривизны минус.
Второй гипотезе тоже имеется гиперболический объем. Значит, все-таки...
Нет, во второй гипотезе это, норма Громова, это когда мы минимизируем сумму коэффициентов в разложении фундаментального класса, кажется, что-то такое, да?
То есть это, да, громовский объем.
Да.
Воль здесь это громовский объем, настоящий, который одной буквы В хватает. Окей.
So I'm going to sketch the proof because
доказывать нужно сначала иметь какое-то определение.
А почему? Все определено.
Ну что такое? Как? В каком? Что?
Okay, no, I will write that there is like an exact formula for them. In our case, it's just computed as follows. Actually, there is a known formula for our knot. So it's not like the quick definitions, so я не знаю, ну, типа, это займет, наверное, какое-то время.
Что такое Е?
Yeah, it's just it's our not just the как обозначение.
В правой части просто вообще никакого нет информации. В правой части какой-то конкретный многочлен.
Yes, and this is это конкретный узел. This is a formula for our 8-figure knot. Yes, and also I can remark that in our formula we have like asymptotic for xi, for model xi more than k, and here we can consider only xi, only positive xi, because our knot is equivalent to its mirror image, and when we write the mirror image of knot, the Jones polynomials is equal to itself with q replaced by q to the power of -1.
Но после того, как эта формула написана, мы вообще все уже забываем. Про топологию, про трехмерное многообразие, про гербердианический объем, и все, больше уже у нас ничего нет.
Ну, по сути, да. Ну, да, то есть как бы тут просто проверить, ну, проверка, по сути, вот в конкретном случае.
То есть
Вот.
в этом случае эти рассуждения, как бы сказать, никакой намек на то, какая за этим стоит геометрия.
Да, вообще никакой, абсолютно. Все, да, то есть все доказательства чисто, мы знаем эту формулу, вот, и просто обычный асимптотический анализ применяем, вот, по сути. То есть, и не знаю, нужно описывать процедуру.
Нет. То есть это...
Вот.
То есть после того, как эта формула написана, уже все, что было сказано до этого, про узлы, гиперболическую геометрию, все это все не нужно, а вот есть конкретная формула, ее нужно посмотреть на асимптотическое поведение при больших n.
Ну и вообще, на самом деле...
Ну, понятно, но все равно, это, как сказать, это уже дальше уже к топологии никакого отношения не имеет.
И вообще, насколько я понимаю, ну, типа, there are some conjectures, but all the checks that are done is done for some known formulas, for Jones polynomials, and just the standard methods for like analytic
Понятно. Значит,
analysis.
в других статьях каких-то были приведены формулы для этих инвариантов, для каких-то конкретных узлов. Они посмотрели на эту табличку, и таблица, и их статья состоит в том, чтобы эти таблички какую-то дать интерпретацию тем ответам, которые там сформулированы.
Yes, but in the proof there are no way to relate these things. So it's just like straightforward computations, analysis, and calculation of the asymptotics. So.
But maybe what's more important is the reason why these conjectures were formulated. This is, I don't believe that they result from just substituting some specific numbers into known answers and then looking attentively at the table of the results obtained.
Ну, наверное, я не знаю, если честно. Вот. Ну, ладно, тогда не нужно или как?
Если у вас есть чем заполнить, более содержательно, лучше, чем другое. То, что, как бы сказать, это вычисление, по крайней мере, уже к топологии узлов.
Да, никакого вообще. Хорошо, тогда я попробую что-то рассказать про... Okay, so as a sketch of proof, I will write like this, like some standard methods, like replacing this sum by some integral, using Poisson summation formula, using some manipulations, Poisson summation formula, and replacing this thing by some integral of the form like f at z the z, and then just the saddle point method. So this is just standard methods for asymptotic analysis of such functions. So now I will try to explain some topological interpretations, but just in this case. So I don't know, should I? Okay, so first I would say that I can describe the P1 of x, where x is some, it's the, as usual, it's like the complement of the tubular neighborhood of our node. And the fundamental group can be described as follows. So if we consider some representation, then we can consider the, I think this is just for this node, but this is a general construction that if we consider these representations, then we can consider the following chain. Я не знаю. Это универсальное окружающее. Да. И I don't know, maybe, and we can consider the thing twisted by the adjoint action of rho, and this is called the adjoint Rademacher torsion, if I'm not mistaken. But also for any manifold, we can just, I think the more general is, ладно, не буду писать, наверное, оставим так. So, yes. So, for any representation, we can consider the adjoint action of rho, and and here, what should P1 act here by our representation rho, and it acts here by the deck transformation. And if we have like some co-chain of such как сказать, такого вида, ладно, не буду писать. Я забыла сказать, да, что нужно. Okay, so first thing is to relate the representation with our number C. It can be done as follows. If we have some representation, let us we want to look at the matrices of its image on the X and Y, and this given by the following thing. Нет, это не оно. Ой. Нет, это я перепутала. Сейчас. So y is this. Okay, so it is stated that if rho is non-abelian representation of our group, then it is up to conjugation can be represented in by the following matrices. Здесь тоже. By the matrices of this form, where D is a fixed number, it is annihilated of some Rayleigh polynomial of the power of 2. So D is, I would say that D is like fixed number. So this gives us the connection between our number C and the representations of our fundamental group. Yes. This D is somewhat the annihilator of this, of some quadratic thing. Okay, so as there is a correspondence between the numbers and the representation, we can. Не знаю, может, что-то сотру. We can now write what is the invariance related to the representation. Yeah. So, yes. So we have this. This coaching. Yes, and also for our node, we could choose the longitude and the meridian as generate. And the Rademeister torsion can be defined as the torsion associated with the meridian, but also actually не очень привычное такое определение, но я думаю, проще будет, если я по-другому скажу, наверное, что когда у нас да, когда у нас есть it's the thing where okay, so what we consider here this one is just the universal covering, so we have the action of P1 on this thing by deck transformations, and also we have the action of P1 on this thing by the row representation. So we can consider this thing, and this is just some cochain complex, and by the cochain complex of this form, we can define. Okay, so we have like this contraction operators, and we can define some G with, if I'm not mistaken. Сейчас как правильно писать. Короче, G нужно в обратную сторону направить. Сейчас, плохо это помню. Да. Чего еще раз? Сейчас, еще раз, какая вторая константа? 1 плюс... Да, да. Ну, как бы, не знаю, что, ну вот она есть. Она... Не, ну тут я говорю, то, что тут просто как бы такой анализ, чисто посмотрели на формулу, вот для каких-то констант что-то там получается. Кстати, ну типа вот, когда просто модуль кси равен k, там совсем другая уже симптотика, там вообще, по-моему, полиномиальной становится вот эта вот штука, вот, поэтому... Ну, не знаю, я, насколько понимаю, тут просто как бы какая-то аналитическая оценка идет. Вот. Поэтому ничего не могу сказать. То есть, как бы известно, что когда модуль кси равен k, там вообще полиномиальная будет асимптотика, вот когда больше, то типа хорошая какая-то. Вот. Так что. Вот, сейчас, секундочку. Чуть подзабыла тут. То есть с нижней, сейчас. Ну вот, это как бы, yes, it's the cochain which is defined just as follows. To define this, we need the action of this here and here. And the action here is just defined by the deck transformation, and the action there is defined by our representation. So, so the ready-made sortation is some generalization of a volume and of the determinant, which can be like defined like this. So if we denote for gravity this thing by G star, then I'm sorry, I just then and also the contraction operator by Dn, then there is gamma such that so gamma from D star plus 1 such that this thing holds. So the radiation torsion of this is just defined, maybe is defined as one by this thing, where A is just the matrix of this thing, which acts from D odd to D even. So it's some. I like meet it like the first time in my life while preparing for the talk. So I don't have like I have no I don't know motivation or something or intuition about what it is, but it is some generalization of yes, and also there is some like statements that it doesn't depend on the choice of basis and so on, but it's some generalization of determinant of the volume for the CW complex. I think it works. So yes.
Я не знаю, Миша Шапира присутствует здесь? Нет, нет.
Yes, I'm here.
You're here. Great. This is some example of flat of the moduli space of flat connections over some bundle over some SL2 bundle. Do you have any intuition of what are meaningful questions that can be asked about the space and in context of not invariants?
I saw some time ago, I saw the paper by two Japanese guys like Nagana, I think, and somebody else. They computed hyperbolic volume and for some nodes, like computing something like that. So you take a sequence of cluster mutations, which realizes the corresponding complement to the node as some hyperbolic variety, cluster variety, and then they compute some fixed points of some transformations, and it's only what comes to the mind. So they exactly computed this hyperbolic volume and Chern-Simons invariant, but it was done only for. They were able to do it only for some very small example.
Yeah, but if they manage to do that using cluster algebra methods and mutations, it's
Yeah, so but in this cluster, so the problem with this cluster stuff is that basically what you do, you compute some polynomial transformation, like x goes to p of x divided by q of x. Well, x is kind of vector. And then you need to compute fixed point of this polynomial transformation, which you have to solve some system of polynomials equation. And I think in general form, it's not clear how to do it. So this sort of thing.
But whether you can always do that numerically or you have to.
Yeah, maybe, I don't know, if you want to get something like square root of p divided by 8, how you recognize this square root of pi divided by 8. If you do it numerically, I have no idea. So
yeah, but usually there are some computer programs which allow one to find expressions like that, provided you know a numerical approximation.
really, I don't know. Maxim is probably specialist. Can you recognize some zeta functions by by
no,
decimal up to 5 points?
That's probably the only way Maxim is unable to do with a computer. But okay, sorry for interrupting.
Okay, so as I said, sorry, I have no intuition for this Rademacher torsion, but maybe. Yes, and the statement about the torsion is that if we are given xi and we consider this representation, and then we consider this cochain, and then we consider this this Rademacher torsion, then we get just the function t of xi. And the second topological invariant is related to the Chern-Simons invariant, and actually the thing is that the Chern-Simons invariant is for not E. Okay, maybe it's better to write the definition first. So if we have free manifold with boundary some torus T, and we have mu and lambda to be the meridian and the longitude, just the generators of P1 of T, and also we have representation rho of fundamental group of the manifold, so SL2. Then we can consider A. It's let's say that A with the SL2 valued one form. one form that let's say that defines some flat connection. Then rho. Let us assume that it can be diagonal. Не могу говорить, ладно. So let's say that for suitable conjugation we have this matrices for the action of our meridian and longitude. So this gives us the relation between the representations and two numbers, alpha and beta. So if we have these two numbers, we can consider the representation which contracted to our boundary will give the following acting, and the opposite way by the representation we can extract these two numbers. So I want to say that up to сейчас как эти yes, it's related, and also it's not like very surprising because there is like AJ conjecture. So I want to say that by the suitable как называется преобразование не сейчас вот забыла с точностью до каких преобразований у нас теория вообще не забыла, ладно. И даже как это произносится, даже не знаю. Gauge. Да. Окей, so вот, калибровочно точно. So up to gauge transformation, our A can be presented as follows. Yes, so and where here this one corresponds to mu and lambda, and then the terms Simon's invariant can be defined. Написать. Красоту. Can be defined as the following thing. It depends on rho or on beta. Actually, rho is related to alpha and beta, and it's just the following кажется так. Вот так можно ставить. Okay. So this is the definition and the proposition, which is, which as I said, is checked just because it's independently known for our node. It's independently known for our node. Then the proposition is the Simon's for our node. for a representation related to Xi in the following way, I would say that nu is some function of Xi, difficult function, is equal to this thing. So this gives us yes, and here yes, we choose the preferred longitudinal meridian, and this gives us the relation of this constant to this topological invariant. So here et of Xi is just some another long to write. It's just some function of Xi which can be written precisely, just some logarithm of something. So this is a general statement that but it's not proven that the Chern-Simons class, which can be defined as follows, it can be expressed through these functions that appear in the asymptotic formulas, but we can check it like just in some baby or not so baby examples, and the main result of the paper is just the proof of this formula and the check of these conjectures. So I think this is all I wanted. Where?
Yeah.
Yeah.
The complement to the figure 8 knot in the 3 sphere.
Yes, yes. Okay, so this is all I wanted to say. Thank you for your attention.
Great. Thanks a lot. Are there more questions? Сейчас это вот maybe it's just some formula, but it's actually this one depends on Xi, so I don't know. Looks a bit like a Laplace transformation.
Laplace, yes, I understand, but I don't know. Here it's just computations.
S is the edge.
Напомните, пожалуйста, у крашеных многочленов Джонса, у них нету всяких типа scaling relation'ов, они как-то по-другому вводятся, да?
Ну, там можно их как бы определять, если мы рассматриваем узел и его дублируем n раз.
Это
Тогда...
как называется каблирование, да?
Да, то есть как бы для них конкретно, да, нельзя написать, но при этом их можно определять, как бы если мы рассмотрим дублирование, рассмотрим как бы отображение вот в алгебру, где есть scaling relation, вот. То есть можно вот так на них смотреть. Вот. Но...
То есть я про то, что такое не, как сказать, элементарное определение этих инвариантов существует или нет?
Ну, как...
Или оно все равно для него какой-то нужно знать теорию представлений, какие-нибудь эти самые R-матрицы или что-нибудь в этом духе?
Ну, и вот такое элементарно, наверное, то, что я вот то, что сказал. Если без R-матриц, без теории представлений, то, наверное, вот дублировать и в алгебру со scaling relation отображать. Вот, и смотреть, что за элементы там получится.
More questions, comments? Okay, then thank you, Sveta. Very clear. The results, at least, are very clear. The conjectures also.
It's clear that the people have no ideas about the approaches to the conjecture.
About conceptual approaches. Great.